I want to do apply the law of cosines. This is what it looks like. It also looks like this on your reference sheet. We can see if I have a squared is equal to b squared plus c squared, or b squared equals a squared plus c squared, or c squared equals a squared plus b squared. It has the feeling of the Pythagorean theorem, which is where the proof is born. Very easy to manipulate and memorize in this one because I have the three different sides here squared. And as I come to the second part with minus 2bc, these are the same sides as I had right here, and the cosine of the angle is opposite the side that I want to find. So if I have cosine b, I want to find side b. Cosine c, I want to find side c, and so forth. All right, now that we've seen that, let's take a look at an example of what this would look like. We want to solve this triangle, and I'm going to set this up very similar to what we did with the law of sines in the last section. So I'm going to put my angle B here, I'll show this to you, as 34. Side A is 11, and side C is 14. And of course I have my B and C like this. All right, so given this then, what I want to do with a law of cosines is I want to find the biggest side, or the biggest angle. Usually that's what I'm looking for. Sometimes it's set up so that I have to find certain sides or angles. I can't use law of sines here because I need an angle and an opposite side. So I have to use law of cosines, which would be b squared is equal to a squared plus c squared minus 2 times a times c times the cosine of 34 degrees. Now, even when I set that up, remember this is for b squared. So what I really want to do is when I finish this, I need to take the square root. So I'm going to just throw a little square root symbol on that. There we go. And then let's go over and find out what that is in my calculator. I'm going to start by throwing the square root in here. Second square root. This is going to be 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of 34. Now, this is 34 degrees, so one of the things I got to make sure is that this is in degree mode. If it's not in degree mode, I'm not going to get anything here. If I press enter, it simplifies it, but what I want is a decimal approximation. So I do my control enter, and I get the length of that side is about 7.9. We'll call it 7.9. I'm not going to get bent out. If you do 7.8, that'll be just fine. Okay. Now that I've put that side in here and I have that angle, I can go ahead and use law of sines. So the sine of 34 degrees over that 7.9, and yes, I know that's an approximation, but that's all I'm going to get out of this is an approximation. And then I want to find the biggest side. So I'm going to go, or for the law of cosines, I want to do the biggest side. If I'm doing the law of sines, I want to find the smallest side. Okay, so in this case, I'm going to do angle A. So this is going to be the sine of A all over 11. Now we did this before in the last assignment. What you're going to do is just cross multiply these guys and divide by 7.9. Let's see that on the calculator. I'll set up my division here. So this is going to be 11 times the sine of 34 degrees, and I want to divide that by 7.9. Now when I do my control enter here, this gives me an approximation, but that doesn't look anything like an angle. And it shouldn't, because I want to find the angle. Hence, I need to do the arc sine. So if I take the arc sine of this one, then I end up with about 51.1 degrees from that calculation. And that's angle A. 51.1 degrees. Okay. So if I stick that in there, now I have my sides. I have two of these angles. To find this last side, what I want to do is simply subtract the sum of those two sides from 180. So this is going to be 180 minus that 51.1 plus that 34, because I know that all the angles add up to 180. So let's see what that looks like. Whoops, other way. So if I go to this one, I can take that 51 and I want to add that to the 34, and then I want to subtract it from 180. Now, you'll notice that I get a negative number here. That's because I'm subtracting that 180, and I just need to realize that I need to change that sign when I'm done here. So this one turns out to be about, 94.9, something like that, which would, which would complete the problem. This is what it would look like. Okay. The steps here again, number 1, apply the law of cosines. Number 2, apply the law of sines. And number 3, solve for the extra angle, like that. All right, that gets us through this one. And I'm just zipping through this. This is on the PowerPoint, and you can see the same thing that we just did right there. And obviously, they got 94.8, which is okay. I'm not really bent out on making sure that you're all that accurate. Just be relatively close. This one is a little bit different. This one I have the 3 sides, and I need to find the 3 angles. So I get my side A is 12, my side B is 27, and my side C is 20. Okay, when I set this up, kind of looks like this. And if you remember the last slide, what I want to do is to solve for the biggest one. So I'm going to go for the cosine of B. I want to solve for B. Now this formula is also on your reference sheet, but if I'm solving for this one, this is going to be my A squared plus my C squared minus my B squared, and that's going to be all over 2 times A times C. Okay, so look that up on your reference sheet. Make sure you got that. What we want to do here is also take the arc cosine when we get done. So let's go to the calculator. I'm going to go Control Menu and then clear out this history so I don't have such a mess here. Setting up my fraction, I have my 12 squared plus the 20 squared minus 27 squared, and that's going to be over 2 times, whoops, sorry, got to put on the bottom, 2 times 12 times 20. Okay. I want to find the angle whose cosine is that, so I do that arc cosine, cursor up, press enter, and then Control enter, and that will find my measurement. Okay, so in this case, this is about 112.7 degrees. Looks like this. And now I can apply the law of sines. So I can take the sine of 112.7, divide that by 27, and since we're using the law of sines, I want to find the small angle, so this would be the sine of A all over 12. Okay, what I'm doing again is I'm finding the angle with that one, and I throw that in my calculator. Here we go. Control divide. I want 12 times the sine of 112.7, and I want to divide that by 27. And when I do this, Control enter, you can see this doesn't look anything like an angle, which is going to clue me that I have to do the arc sine. So I take the arc sine of that measure, and I get my angle here, which is about 24.2 degrees. So I want to record that, 24.2 degrees, and there it is. Well, like we did last time, I apply the law of cosines, I apply the law of sines, and I want to find this third angle. To do that, what I do is take 180, and I'm going to subtract the sum of that 24.2 plus the 112.7, and that will give me my angle C. So let's do that in the calculator. Whoops, other way, the calculator. Here's my 24 plus my 112.7, and I want to subtract that from 180. Looks like I get 43. Now remember that I have to drop that negative. You're never going to get a negative angle for any of these guys. So about 43.1 degrees, something like that. Okay, allows me to solve for the triangle. So those are really the only 2 things that you need to worry about here. Again, you can see the steps that we went through. First one is apply the law of cosines, then the law of sines, and then finally subtract your angles when you get there. Okay, so that's that part of the law of cosines. The next thing we want to do, and we're going to just kind of zoom ahead here. I'll let you see what the solution was here. Yeah, that's a little quick. But this is what we got when we did this one, right? Okay, so the next one here is called Heron's formula. Heron's formula is going to...
Could you try again?
I will, Siri, thank you. I want to find the area of the triangle. To find the area of the triangle, I need what we call the semi-perimeter. That's that S that's down below there. So S is going to be equal to 1/2 the sum of A, B, and C. So I'm going to add up A, B, and C, which are the lengths of the side, divided by 2. Now that's what we call a semi-perimeter. It is not the average. Now A plus B plus C is a perimeter, but this is a semi-perimeter. And then I want to get the area, which is going to be S times S minus A times S minus B times S minus C. This formula is also on your reference sheet. Let's do one of these and show you what it looks like. Okay, I don't want to do the herbal planning because that's kind of involved. Let's do something easy. There we go, like this one. So if I look at this, I can see that my A is going to be 8, my B is going to be 11, and my C is going to be 5. It's just the lengths of the sides opposite the angles. Okay, throwing this into my formula, I can see 8 plus 11 plus 5 divided by 2. That's going to be my semi-perimeter. Let's see, that's 24 divided by 2. That looks like 12. Okay. Then the area, which is what I'm really looking for, is going to be the square root of S, which is 12, and then S minus A. Well, if I take this 12 minus 8, I don't need to throw that in calculator. I can see that that's going to be 4. And same thing with 12 minus 11. And same thing with 12 minus 5. I can do all those without the aid of a calculator. But as I get here, maybe I want a calculator. So let's throw it on the calculator. Control menu and clear that out so I don't have to look at that junk. This is the square root of 12 times 4 times 1, which I'm not going to put in there, times 7. Okay, I get 4 radical 21, but I want a decimal approximation. So this should be about 18.3 units squared, whatever that happens to be. I'll go ahead and accept 18.3. That works for me. Okay, so here is from the PowerPoint. You can see they've done the same thing, and they got the 18.3. All right, this is your key to using the law of cosines and Heron's formula, and hope it works for you. Thanks.